So this field day is sponsored by a Southern Sayer project. They funded an on-farm research project for our work on this farm with Eric Wallace. This is his farm, Berries on Bryan Station. The focus of the Sayer project is on mechanization for organic production, organic vegetable production. It doesn't have to be specifically organic. The machinery systems we're going to be looking at today apply to conventional as well. But I want to emphasize an aspect of this project, the grant that was funded and the work that I've been doing. It's the idea of taking market growers, what I consider relatively small but viable and hard-working vegetable production, primarily for farmers markets and CSAs, maybe some restaurant supply, and looking at how you can take them to the next level. We started working with this thing 3 years ago. This three-wheeled configuration was developed by Larry Swetnam as a tobacco harvesting aid, about 35 years ago. And some of these machines are still around. And Terry Jones had a machine at Quicksand at Robinson Station. And we got the machine from Terry Jones. We rebuilt the front end. And we realized that we could do the tobacco harvesting aid was self-guided on the standing tobacco stalks, so that you didn't have to have a driver. We could use it to harvest tobacco. We realized that we could do something similar because the steering on this machine is mechanical. There's a chain and sprocket on the steering. There's no gearbox the steering goes through. So we realized we could put out guidance arms out front, and this thing will follow a furrow. And so as we developed this system, what we came up with was we make wheel tracks in freshly tilled ground the first time we run the machine with our narrow front tires. And then we can use those wheel tracks for nearly perfect guidance, self-steering on the road, and that's especially good for cultivation. We can cultivate pretty close to the plant after we production, and this is part of this Sayer on-farm research project that we have. What we have here is a crop of potatoes that were planted on the 7th of May, and these two rows here are potatoes that Eric planted, for him conventionally, but they're organic. These two rows were planted. He used a plastic layer to raise the bed, but he didn't put down plastic. He put down T-tape, but no plastic. Then he came back and planted manually into these beds. He planted a double row, so you can see this looks pretty thick and looks really good. He planted by hand, and Eric's pretty efficient, but he was scooting on his bottom to plant. And it was hard work, but he was pretty fast. And he had perfect soil conditions for planting into. Then these 4 rows that you see are what we planted with the three-wheeled machine, like I demonstrated earlier this morning. It was faster than what Eric could do by hand, not as much as you'd think, but it was awfully easy. So if you were going to do a full acre of potatoes or 2 or 3 acres of potatoes, you can imagine this is a lot easier to do. The other thing about these potatoes I want to point out, we did a single row. They don't look as thick as Eric's. He did double rows. We're planted on 42-inch row spacing here. With this machine, I didn't point this out earlier, but it has adjustable front row spacing. We can go anywhere, and we've got it standardized to where we do a 3-inch row increment. So we can go as close as 36-inch row spacing. 42 is what we like for most things. We can go up to a 48-inch row spacing. And if you're familiar with organic production principles, one of the things weed control is the biggest challenge. And the closer spacing you can use, the less bare ground you have. You get canopy closure soon, and that helps with your weed control. So if we can plant closer using this 3-wheel machine with the furrow guidance, that can be a benefit for organic production. So anyway, these 4 rows of potatoes where Larry is with the video camera, these have been cultivated twice using the furrow guidance, and then they've been hilled. And so and you can see what they look like. These have had no manual weed control. They're grown organically, no herbicide, no mulch, strictly cultivation and hilling. All right, so I've actually done these 2 cultivated and hilled. Where Larry's standing, those have not been cultivated or hilled yet, so I'm going to demonstrate that in a minute. Now, the next thing we're planting with as part of our SARE grant is beets. And for the beets and other similar crops, okay, so we're planting beets, and actually one of the planters is going to be planting standard beet seed, and the other one's going to be planting coated beet seed. Those of you who are vegetable growers may have had some experience. The first time we did this, we used these older Planet Junior planters, and they're fairly easy to rig up to this machine, but they're not very good at precision seeding. So this year we borrowed these 2 Jang seeders. These are what they're Korean made. We got one of these from the South Farm and one from a grower, Aaron Stancomb. So they seem to work pretty well. We rigged up our own toolbar and mounting set for these. These are actually designed to be the push seeders, manual seeders. But this machine is very adaptable to doing that kind of thing. All right, Charlie. Right, planting. So I'm going to direct seed right over the where we just laid drip tape.
How close are you going to plant, John?
We're shooting for about 3-inch spacing, which I don't know how close we're coming. We worked on checking it yesterday. Lost my earplugs. I'll do my earplugs. And we're planting, I think we are at about 13 inches right there apart.
and make it easier to produce a lot of vegetables on a small farm like what we have here in a more efficient manner. This piece of equipment here is to help automate planting into the black plastic with the drip irrigation. We use the black plastic so that we do not have to use herbicides. Many of the herbicides do a great job of killing the weeds, but they end up in our drinking water, they move up into the plant, and residues. This piece of equipment is designed to straddle the black plastic row. One of these wheels goes on either part of the plastic, has a vertical seed plate. The power takeoff of the tractor creates a vacuum here, and the vacuum pulls onto the seed plate here, and as the steerage mechanism is on this tire. As this tire moves, it moves the seed plate, and it picks up 2 seeds and drops them through these chambers here. These chambers punch a hole through the plastic, drop 2 seeds, and then this wheel covers up the seeds under the plastic. And we've been so excited because in 2 or 3 days of using this piece of equipment, we put more seed in the ground than we typically plant in 2 months. And with the 3 seed plates, we can plant with this planter about 35 different kinds of vegetables. So we only have 3 seed plates, but with those plates, we can plant a great variety of vegetables. And we've already tried beans. Today we'll be planting beets, but we've planted beans, beets, some small seeds, some big seeds. One learning we did find out was we had a very small, thin bean. And if the seed plate was too large, it broke the bean. So one of the principles with the seed plates is you want the seed plate approximately the diameter of the seed that you're picking up, but no larger.
Down the chute, and it'll come out right at the same time. As the hole puncher punches the hole, the back wheel will firm it down as it goes. Now we're electric drive, so very quiet. We have the generator, it's on standby. As we start pulling down the batteries, it will kick on. If we need to, I'm not sure if we're going to pull enough to actually use it. We've got independent electric motors on each wheel. They're about 10.5 horsepower on each one, so this tractor is about 20 horsepower. Notice it's independent steering instead of like over there where it's a single engine. But you can control it here. We drive forward.